All right, we're going to verify some identities using the double angle and half angle identities that we learned the other day. We're going to start with example 1, which says sine 2 theta over sine theta minus cosine 2 theta over cosine theta equals secant theta. So the left-hand side is much more complicated than the right-hand side, so I'm going to start there. And I'm going to replace sine of 2 theta with the double angle identity for sine, which is 2 sine theta cosine theta, and then we'll divide by sine theta. And then I'm going to replace cosine of 2 theta with one of the cosine identities for the double angle. And our options are cosine squared theta minus sine squared theta, 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. Now, I'm trying to get to secant, which is 1 over cosine, so I don't want to add any additional signs to the problem. So I'm not going to choose this first one or the third one. I'm going to choose the second one because that's in terms of cosine, and I have this cosine on the bottom as well. So 2 cosine squared theta minus 1 is the identity I'm choosing, and we're going to put that over cosine theta. So now in the first term, the signs will cancel, and we'll be left with 2 cosine theta. Now the second term I'm actually going to split into 2 fractions. It'll be minus 2 cosine squared theta over cosine theta. And then I have to distribute this negative, so it becomes a plus 1 over cosine theta. So now this cosine theta cancels with one of the cosine thetas in the numerator, and we're left with 2 cosine theta minus 2 cosine theta plus 1 over cosine theta. Now these two make 0, and so we're just left with 1 over cosine theta, which is secant theta, which is what we were trying to prove. On to example 2. Alright, now it looks like the right-hand side is more complicated than the left-hand side, except there's an identity for tangent of 2x. The identity for tangent of 2x is equal to 2 tangent x over 1 minus tangent squared x. So I'm actually going to start on the left-hand side on this one. And I'm going to leave the 2 alone. And now cotangent is the reciprocal of tangent. So that means that the cotangent of 2x is a reciprocal of tangent of 2x, which is 1 minus tangent squared x over 2 tangent x. So the 2's cancel, and I'm left with 1 minus tangent squared x over tangent x. Just like the previous example, I'm going to split this fraction into 2. It's going to become 1 over tangent x minus tangent squared x over tangent x. Now 1 over tangent x is cotangent x. This tangent in the denominator of the second term will cancel with one of the tangents in the numerator, and we're left with tangent x. This is what we were trying to get to, so this identity has been verified. Finally, example 3. The right-hand side looks more complicated than the left-hand side, so we're probably going to start there, but let's remind ourselves what the half-angle identity for tangent is. It's going to be sine of beta over 1 plus cosine beta, or you can multiply both of these by the conjugate of the denominator, and you would end up with 1 minus cosine beta over sine beta when you simplify that. Now, because I have a single term in the numerator and a plus sign in the denominator, I think I'm going to try to get this, the first one that we wrote down. So starting on the right-hand side, I'm going to change to sines and cosines. So that's 1 over cosine beta for secant beta, 1 over cosine beta times 1 over sine beta for cosecant, plus 1 over sine beta. Now in the numerator, I'm trying to get a sine beta. So I'm going to multiply by a 1 that's going to help me out. So I'm going to multiply by sine beta cosine beta. And then if I do that in the numerator, I have to do the same thing in the denominator. And putting over 1 is optional. You don't have to do that. It's just if it makes it easier to multiply, then go ahead and do it. Now in the numerator, this cosine beta will cancel with the cosine beta in the numerator of the second term there, so we're going to have sine beta. And now in the denominator, I'm going to need to distribute this through. So when I distribute to my first term, 1 over cosine beta times 1 over sine beta, the cosine beta will cancel and the sine beta will cancel, and I'll be left with 1. Now in the second term, the sine beta will cancel, and I'll be left with cosine beta. And you can see that equals the identity, which is the half angle identity for tangent. So we can replace it with tangent of beta over 2, which is what we were trying to get to on the left-hand side. So this identity is now verified.